Hi everyone, welcome back. So in this week's lessons, we're going to be talking about colors and textures. We're going to do a few examples that are going to be exploring how we can use these ideas in a generative context. We're also going to be drawing from some of the things we've been covering up until now. So the idea of the grid, vectors, parallel and we're going to be tying some of these together into some of the examples we're going to be walking you through today. So let's get started. So I've already remixed the sketch here, just a blank sketch, and I've called it color grid. So the first example we're going to be developing, we're going to be looking at how do we generate random colors by drawing from a palette of colors as opposed to just completely random. And we're going to do this in a couple of ways. We're going to just first create our own kind of custom color palette, and then we'll also talk about how we can bring in images as a source of colors. So let's start by giving ourselves here something to work with. We're going to revisit the idea of the grid. So let's create a variable called grid. That's going to be our grid size, the size of each cell in the grid. And then we'll build the two nested for loops that will allow us to generate all the coordinates, the XY coordinates for the grid. So that one will generate the X coordinates, and that one will generate the Y coordinates. Okay. Now inside this for loop, just to make our lives easier down the road, we're going to use push and pop to save and restore the origin. And then I'm going to also use translate to move the 0, 0 point essentially to be at the corner of the grid here. And then let's see that it works by drawing a little square. Okay, so we have a grid. Pretty useful little pattern. Now for this example, we're going to also just vary things around a little bit by instead of setting the 0, 0 point to be the top left corner of one of these grid cells, I'm going to make it to be the center of the cell, just for the little pattern we're about to draw. No other reason that it will make life a little bit more convenient. So if I want to shift this 0, 0 point over to the center of each cell, I'm just going to add half of the grid variable to X and Y to bring the 0, 0 point in the middle when I translate. So I'm going to do that right here. So I'm going to do plus grid divided by 2. Then I'm going to change rectangle mode to center before we do this for loop. And now I've reshifted all the rectangles in the right place. The only difference is now 0, 0 is actually in the center of each cell. And then just for the sake of this simple little example, let's do another rectangle, except we're going to make this one half the size. Okay. So now we just have two nested squares inside each grid cell. So our first exercise is going to be, let's assign some colors to these. And let's start with completely random colors, just to see what will happen. So let's create a variable here. I'm going to call it C1 for the first color. And we're going to say this is going to be equal to a color. I'm going to use the color function. And let's start with some gray values. So let's fill using C1. Oh. All right. Let's also throw a no loop in there just so we can pause the sketch and just see what we get. So here we're getting random gray levels. Let's generate a second one. I'm going to call it C2. And we're going to use that fill for the second inner rectangle. Now it looks like that. And let's disable the stroke. I don't know, just why not? So we've got a little pattern here and we're just generating some random gray levels. Now, if we tried to switch over to colors, what we could do is we could just do this 3 times, right? A color is an RGB component. So we could generate 3 random numbers. Okay? That's going to generate a random color for the bigger box. And then we're going to copy and paste this over here. And we're going to generate a random color for the smaller box. And this can be interesting, but the thing with purely random colors is that they're all over the place. Just when we talked about using random to animate a line or animate a point, random can be a useful tool when we're playing with generative processes, but it is a little, it's hard to control it because it's really unpredictable. So here we're getting this not super aesthetically pleasing mishmash of colors, unless this is like the very aesthetic you're going for. So when we try to generate random colors, it can be helpful to narrow down the set of colors we're choosing from by selecting a color palette of colors that go well together. Let's see how we could do this. So the palette here could be as simple as just an array in which we could put in some colors in there. And there's lots of different formats we can use for the colors. We can use RGB. We can also use HTML color. We could come up with these colors just from scratch, right? Or one thing I like to do when I'm just looking for colors that go well together is to turn to some kind of color palette generator website. There's many of those out there, but here's one that I like to use. It's called coolers.co. Okay, there it is. So this is one of many sort of color schemes or color palette generator, and it's got a few interesting features. One is you can look at popular palettes, for example. You can also generate totally random ones. We can see there's a bunch of already interesting color palettes that are just seems to be favorites. Let's take this one. I think I kind of like that color scheme here. So once we have a color palette, we can export it, or we can open it in the generator. So let's do that. So here's my palette. There's lots of tools in here that we can, you can lock a color, you can randomly generate new ones. Feel free to explore that website to see what can be done here. One reason I like to use it is because it's got a convenient little feature here with the export menu. So one of the formats you can export to is called code. So if I click on this button, it will give me a few different options of how to export these colors as JavaScript structures. And one of these is an array here. So I'm going to grab the array and it's containing all the sort of HTML style color names. Just going to copy that and then paste it into my color palette array. I've got some extra square brackets. Now in P5.js, the only thing we have to do to these colors before we can use them is we have to add the pound sign in front of them. So we're just going to do that manually. There's only just a handful of colors here, so it's not too onerous. And now we have an array that's filled with the color palette, right? That was available on this website. So now that we have an array of colors to choose from, instead of generating completely random colors, what we can do is just draw randomly from that array by using the random function. So we're going to write random palette for C1. And you can see now the bigger square, the color is coming from the palette. And then we'll do the same thing for C2. So this is a really nice way of essentially constraining the range of colors that's available to your composition. So just kind of curate or select, a few colors that go well together, and then you can randomly choose from that set, and it's going to be a lot more cohesive and coherent. Now, one thing that's happening here, I just want to point out before we move on, is some of these cells here in the grid, we're choosing the same color twice because there is only 5 to choose from. And that could be okay. There's nothing wrong with that. Actually, maybe you can find it adds some visual interest to the pattern, so we can decide this is our algorithm, we leave it like this. But let's say we wanted to maintain this 2 square pattern, and we wanted to make sure that each cell got some random colors, except we don't want them to be the same color. We always want to get 2 different colors from this palette array. Here's a cool trick we can use to do this. So what we're going to do is first we're going to just define C2 by itself. So we have the variable there. And then what we're going to do is put this little bit of code here inside a while loop. Now, what the while loop does, if you'll remember, it says while something is true, right? Repeat. So it's going to keep repeating as long as the condition inside the while loop is true. So one nice trick we can do here, and we got to be a little bit careful with this because we don't want to create a situation where we have an infinite loop. we're going to say, as long as C2 is equal to random palette, right? So this is going to evaluate this statement inside the while loop question portion. And then I'm going to put this into parentheses, right? So the result of this statement is going to be the value that gets placed into C2. So we're going to say here, as long as this is equal to C1, right? So if we ever get the situation where C2 is the same as C1, if this in other words, if this whole thing is true, then we want the while loop to repeat. So this while loop is going to continuously select a random color until it finds one that is not equal to C1. So this is kind of a nice trick. And then I just put a semicolon here because we don't actually have anything to do in the body of the loop, because everything is taking place here inside the question section of the while loop. So if you notice on the right here, I no longer have the situation where two of the cells actually have the same color. All right, moving on. So another way that we can approach creating color palettes inside a sketch is using an image as a source of colors. And this is something I like to do quite a bit. So there's a few ways we can approach this. If we go back here to coolers here for a second, one of the features that this website has is you can pick a color palette from a photo. So you could upload an image and then it will generate automatically a color palette based on the dominant colors inside that image. So this is a perfectly fine way to do it. And then you would also just grab the palette in the same way we've just did and then bring that into our sketch. But just for the sake of doing something a little different here, let's bring an image into our sketch and then write some code that will turn this image into a color palette. So I'm going to close these tabs. This is also going to allow us to talk about bringing assets and images into a sketch within glitch.com, which we haven't done yet so far. So for today's examples, the image I'm going to work with is just a JPEG file here. It looks like this. It's a highway interchange. We're going to use it through all the other examples for the week. You can use whatever image you have kicking around. I just went on Google Images, found this image, and I selected it because for a few reasons. It has interesting lines in it. And I like the color scheme of this image. It's got these autumn trees and some greens, and then the concrete from the highways and the lighting. I like the colors in that image. So what we're going to do is bring that into our sketch and then extract these colors to use as our color palette. And we'll see there's a clever way we can do that without too much work. So the first thing is, let's talk about how we would bring an image into glitch.com, because there's a few gotchas you have to know about. So back to Glitch here, if you click on the new file menu, you can upload a file, which we're going to do right now. So I'm going to go on my desktop, look for this image, and I'm going to upload it. Now, what happens when you upload a sketch, an image to a sketch on Glitch is it gets placed inside this section called Assets. So if you notice now, this is my sketch. And then if I click on Assets, I have this, only one asset right now, I have this image. And if I click on the image, we're going to see there's a link. Okay. So if we want to refer to that image, if we want to load that image inside our sketch, we are going to use this URL. Meaning that the image doesn't just live in the same folder as sketch.js and index. So we cannot just refer to it by its name directly. We need this full URL. This is where the image is being hosted on the Glitch server. So I'm going to copy this URL here and then go back to my sketch. And I'm going to put it inside a variable for now. So it's quite a long string, but I'm just pasting it here, and this is what it looks like. Okay. So now this variable highway contains the URL to my image that I've uploaded into my assets that is being hosted by Glitch. So now let's load that image into our sketch. Now, generally, if you're going to be working with loading images and assets in a P5.js set sketch, you have to think about file loading times because we are in a browser. So this is a little different from processing, where running everything from the desktop, kind of everything loads more or less instantaneously. In the browser, you sometimes have to wait for an image to get downloaded before you can use it. So P5 has a function just for that called preload. So preload is kind of a pre-setup where you can load assets, images, for example, and the function will wait for these assets to be loaded before moving on to setup. So it will make sure that your objects are available when your sketch starts. So let's make a global variable here. I'm going to call it img. This is short for image. I cannot use image because there's already a function that has that name. So we'll just use img. And then in preload, we're going to say img equals load image. Now this is where we would put the file name of the image we want to load. And notice now I've put in a preload here. It says loading. So the file name of my image here is inside the variable highway. And I could have also just pasted this URL directly into here. But let's say, down the road, I want to try different images and kind of go back and forth between them. Having some variable names here is going to make that a little bit easier. So now I've loaded this image. And just to make sure that it is in fact working, at the end of our draw loop here, I'm just going to throw that in there. We can draw images just like in processing using the image function. Okay. So I'm just drawing my image here at 0, 0 and just going over top my pattern here. And we can see it's being loaded. It's actually wider than I have space here in the canvas, but that's fine. Let's delete that line. Let's go into setup here and see how we would extract colors from an image. Okay. This is also a good time to point out we can use this thing called the console in the developer tools in Chrome. Now, what am I about to do? It only applies to Chrome as a browser. So I really recommend you use Chrome for a lot of these exercises. But there's probably something similar in other browsers as well. So in Chrome, under more tools here, under my tools menu, I have this thing called the developer tools. So if I open this, I'm going to resize here so we can see my code. I get this tab here, which a bunch of options. I've zoomed it in a little bit so the text is slightly bigger. And this is my JavaScript console here. So what I can do in this, I'm going to clear the errors here. Okay, don't need to see the issues. So what I can do in this console is I can actually just live type some JavaScript code, and it will evaluate it. For example, I could create a variable called a equal to 10. I could print this variable. Oops, that's actually sending a command to my printer. I could say, a plus 10 equals 20. So I can run some JavaScript code on the fly inside this little console. So if I wanted to examine some of my global variables, I could also do that. Now there's only one little catch here. So if I try to type the image variable, okay, it doesn't actually exist. It says there's no reference to it. That's because by default, the console is sitting in this frame here, which is the top frame of the entire browser window. Now in Glitch, the actual section of the browser that is running our program, if you scroll down here, there's a window where you can set, which portion you're interested in. You're going to find one of these here that has the name of your sketch at glitch.me. This is actually the frame. If I select this here, this is the frame that's in the middle that's actually executing my code. Glitch has a lot of different HTML elements for the code portion, the file portions, and so forth. So I'm going to make sure I select the part that's actually running my sketch here. And now I can refer to the variables that are in my sketch, right? I can type image, I can type, highway is a string, grid is the number 40. So I can actually interact with my sketch in real time. So an image object in P5.js has a pixels variable. Now the pixels is an array, okay? And by default, it is empty. So you can see here I have an empty array. So if I want to be able to access the pixels of an image, I have to say image.loadPixels. And there's something similar going on when you use processing as well. So after I've loaded the pixels, if I say img.pixels, I'll see that there's an array here. It's going to be quite long. If I print it, because it's every single pixel in my source image, there's a giant array here that's made up of a bunch of numbers. Okay? So the way the pixels are stored inside the image.pixels array is you have a sequence of numbers starting in the top left of the image that represents the red, green, blue, and alpha component of a pixel. So actually first let's make the source image, we're gonna shrink it down a little bit. So I'm gonna say image.resize. I'm gonna make it 4 by 4. So resize it here. Okay, so now the image has a width of 4 and 4. We'll say load pixels, just so we can see the pixels a little bit better. Let's log the pixels. Oh, sorry. Img.pixels. Okay. So this is now the content of my pixels array. So I've taken my source image, that's the highway interchange. I've made it extremely small, so I've resized it to be a 4 by 4 pixel image, and we'll talk about why in a minute. And then this is now the contents of the pixels array. So every 4 of these numbers represents a color in that image. So you can see this is the red, green, blue, and then alpha. Red, green, blue, alpha. All the alphas are 255 because there's no transparency in that image. Red, green, blue, alpha. So what we're going to do is iterate through that array and extract all of these color values, right? Turn them into color variables and then put them into our palette. So let's do that inside a setup here. So let's write a for loop that's going to count from 0 to the number of pixels that we have. We don't need the console anymore. And we're going to step through this array in steps of 4. Okay. The reason we do steps of 4 here, because we have red, green, blue, and alpha as 4 consecutive numbers. So in the for loop here, let's extract all of these values from the array into some temporary variables, so we make it very clear what's going on. So we'll say the red component will be image.pixels bracket I. Okay? Then the green component will be the following number in the sequence, which is I plus 1. Then the blue component is going to be I plus 2. And we're going to just ignore the alpha because we don't care for this example. So let's all of these 3 things be combined together into a color. So we'll say RGB. Okay. And then take this color and add it to the end of our palette. And now we should be able to get rid of palette. All right, I just realized that I made a small omission here. I forgot to add load pixels. So unless we add this command here, the pixel array will be empty. And then we're going to just comment out here the while loop, because I also noticed there's a small other issue there. And then we're going to reload the page. Okay. All right. Let's just stick to 2 random colors for now, and we'll revisit why this was a bit of an issue in a second. So now we've taken all the possible images, all the possible colors from this image, right? And added those into our color palette. Now this is a reduced version of the image. The reason I shrunk it down is because let's say we could make it original. Let's say 100 by 100. So it's going to take a while to generate this color palette. I could even not resize it at all. And then every single color potentially is going to now be part of our palette. We're going to have literally tens of thousands of colors in there. And this is going to take a while to generate. It's also going to take a while to randomly choose from the palette over time. So this is a little bit too slow. So the reason we resize the image, sorry, is just to cut down on the number of available colors. So something interesting happens when we resize the image. What it does is it has its own internal logic as to which colors it selects when it makes the image smaller. And that allows us to narrow down the color palette that we want to get from the image. So if a color is really dominant in an image, it's going to remain in the smaller version of that image. So you can play around with this, and I could make the image as small as 2 by 2. Now I'm getting these very muted tones here. I could make it as 4 by 4, I'm going to get a slightly different color palette. So this is something that's interesting to experiment with. So by making the sub image a little bit bigger, I'm allowing some of the orange and yellow tones in there from the leaves around the highways, right? So this is another interesting strategy to generate color palettes from an image instead of just a straight up list of colors from a website. And basically by replacing this URL with a different image, you're going to get a completely different color palette that retains kind of some of the mood of that original image. Now, one thing you'll notice, I've commented out this little trick we did over here, and I want to point out I've caused a little bit of problems for myself here by doing this. What we're doing here, it works because we're comparing C1 to C2, which used to be strings, okay? And now we've made these into colors. So what we're going to do is here, we're going to add toString over there to the color that we put in our palette. And this is going to have the effect of converting this color into a string instead of a color object. Unfortunately, if you compare two color objects, even though they have the same color, they're not going to return the same. They're not going to return true if you compare them. JavaScript will still think they're different objects, even though they have the same color in that context. So what ended up happening is we would get an infinite loop because it would struggle to compare here the objects from the palette. So now if I put this back, this will work. Now that we have an image loaded into our sketch and some kind of a grid framework in place here, what we're going to do in the next lesson is look at how we can also use the image itself as a source of interesting texture elements in a composition. So I'll see you in the next tutorial.